Hello engineers, welcome to the new video of the course, and in this particular video we are going to see that how exactly a doping can be done. Okay, so there are lots of ways through which we can do doping, but I had only considered two ways, okay, or the two methods of doping. But before coming to understanding the these two methods, like how exactly we perform doping, we first need to revise the concept of doping, that what exactly a doping is. So let me go to the previous slides where we had actually focused upon this particular topic. So you can see over here what is doping. So doping is nothing but a mixing of impurities with the pure crystal or pure semiconductor or intrinsic semiconductor. So this is the basic idea of doping. Again I will repeat, when you are mixing the pure crystal of semiconductor, or rather instead of calling it as a pure crystal of semiconductor, I will term it as intrinsic semiconductor. Okay, so in an intrinsic semiconductor, when you are adding or when you are mixing certain impurities, so this particular process is known as doping, right? And the impurity atom, it is known as dopant. Okay, I hope you are able to understand this. Great. Now we will focus upon the different methods that are used in doping. So the very first method is heating pure semiconductor in the atmosphere of impurity atoms. Okay. Alright, so as you can see over here, this is my crystal, and inside that particular crystal there are lots of atoms, right? I just represent it in the normal way, okay, because I want that you all guys should understand the concept. Okay, so let's assume that this is my pure intrinsic semiconductor. So this is my intrinsic semiconductor, okay, this is my intrinsic semiconductor, and for time being I will assume it as a germanium crystal. If you want, you can assume it as a silicon crystal as well, right? So there are lots of germanium atom inside it, and you can see the surrounding atmosphere. Okay, in this surrounding atmosphere I had intentionally placed certain impurity atoms. So this purple color circular like structure, it represents my impurity atoms. Okay, in the surrounding atmosphere, impurity atoms. Okay, these are my impurity atoms surrounding to this particular germanium crystal. Okay, so now what I will do, I will just heat this particular germanium crystal or this particular intrinsic semiconductor. So I will write over here what I am going to do. I will just heat this particular germanium crystal. So I will heat over here. So this line indicates that I am hitting this particular germanium crystal. Okay. So now let me move to the further page and let me just explain you what exactly is going to happen. See, when you heat any material, so what that material do? It will try to expand itself, right? It will try to expand itself, right? So this is what we will see in the case of germanium crystal as well. And as it is expanding, so what is going to happen? See, due to heating, expansion of germanium crystal will happen, right? And due to this, the intermolecular, the intermolecular distance between the germanium atom, it increases, right? Again I'll repeat, see, due to heating, see, I'll just move this over here. Yeah. So due to heating, what is going to happen? Due to heating, obviously this is the natural tendency of any material. When you provide heat to that particular certain heat to that particular material, it will try to expand itself. After that, what is going to happen? Since it expanded, so what is going to happen? The the intermolecular space between the atom, it increases, right? So what is intermolecular space? Nothing but the distance between two of the atoms. It will increase, right? And as the distance between this atom increases, so what is going to happen? This the impurity atom which is present in the surrounding atmosphere, so it will try to it will try to accommodate itself in this particular space, right? It will try to accommodate itself in this particular space. Okay, so this is how we do doping. Okay, this is how we do doping with the help of very first step, and that is due to heating. Again I will repeat the entire process. See, I have this germanium crystal which is a pure intrinsic semiconductor, and surrounding to it I had intentionally placed in the surrounding atmosphere, I had intentionally placed impurity atoms, right? And after that, what I'm going to do, I will heat this particular germanium crystal. After heating, what I'll say is the germanium crystal first it will try to expand itself, and since it got expanded, so what is going to happen? The intermolecular distance or the intermolecular space between the germanium atom, it is also going to increase, right? This is what I had shown, the intermolecular spaces between these two. See, this particular atom, again I'll show it to you. It is going to increase, it is going to increase, and whatever the surrounding atom that is present, or surrounding impurity atom that is present, then it will try to accommodate itself over here. Okay, so this is the actual idea of doping with the very first step, that is due to heating, right? Heating pure semiconductor in atmosphere of impurity atom. So this was, the very first step. So let me just write the point so that, whenever you will refer my PDF, it would be pretty easy for you to understand and to deduce certain things out of it. Okay, so let me just write the very first point, and it states that, let me select one color. Yeah, I'll just write over here the very first point. Due to heating of germanium crystal, the intermolecular spaces, expansion. I just need to focus upon this particular point. First, expansion will take place. Right? So see, again I'll repeat, due to heating of germanium crystal, expansion of germanium crystal will take place. Okay, expansion of germanium crystal will take place. Okay, and after that, what is going to happen? Expansion of germanium crystal will take place, and second point will be like this. Due to which the intermolecular spaces, let me write it properly. Due to which the intermolecular spaces, or the distance to intermolecular space or distance, distance between the atom increases, or between the germanium atom increases, right? Between the germanium atom increases, and due to this, what is going to happen? Let me write the third point over here. So impurity atom try to accommodate or gets accommodated in this particular intermolecular space. Okay, gets accommodated in this intermolecular space, intermolecular distance between the atom, or the space between the atoms, right? Again I will repeat. See what exactly happened. Due to heating, the germanium crystal will expand. This is what I had shown. First it got expanded. After that, what is going to happen? Due to which, as you can see, the intermolecular space which was created over here, in that particular intermolecular space, the impurity atom which was present in the surrounding of this particular germanium crystal, it accommodated in that particular intermolecular space. Okay, so this is how we do doping, by heating. And after that, this is the second way through which we can do doping. As such, there are a lot of ways, but I'll just focus upon these two ways. Okay, second step, or the second method is not step, sorry, the second method through which we can do doping is by bombarding pure crystal with ions of impurity, okay, or basically impurity atom. Okay, so you see, this is how we actually do over here. So as you can see, this is my impurity ions or impurity atom, right? So what I will do, I'll just bombard them. Okay, the velocity would be quite high, right? The speed would be high. Let me just show it to you here. Speed would be high, speed would be very high. Okay, and when we bombard this particular atom, then what is going to happen? This atom, it will eject the atom of germanium, and it will be taking place of that particular atom. Don't worry, I will explain you. See, this is how it will look like. Okay, so let me just show it to you over here. Yeah, you see this particular atom. Okay, it has certain speed. Obviously the speed is very, very high, and this is my germanium crystal, and in that particular germanium crystal there are lots of germanium atom. Okay, so now let me just place it somewhere below. Let me just show to you how exactly it will work. So see, this is my this impurity atom. It is coming at very high speed, and after that, see, over here it will do certain impact, right? As soon as this particular atom is hitting at this particular point, so what is going to happen? This particular atom which is present over here, it will come out, and this particular atom which was present over here, it will be accommodating its space. Okay, so you see with the bombarding how exactly it works. See, again I will just move it away, and this one I will move it over here. See what exactly it had done. It had done is that, see, this particular impurity atom, it got strike at this particular point, right? It hit at this particular point, and after that what is going to happen? Now due to the collision, this particular atom which was present over here, this particular germanium atom, it will come out of this particular crystal. Okay, and this particular atom, then it will take place of the germanium atom, right? So this is the basic idea of this particular method. Okay, I hope you are able to understand this. So basically we are bombarding the impurity atoms onto this particular germanium crystal, and due to this what is going to happen? The germanium atom would be getting swapped with the impurity atom. Okay, this is what we can see. Okay, great. So let me just write over here, but before that, let me move this. I'll just delete this. I'll just keep this particular diagram so that whenever you will refer my PDF, it would be pretty easier for you all guys to understand this particular concept. Okay, as such, there isn't such difficulty understanding this particular point. These are very simple and easy to understand process. So let me just write over here. In this process, we bombard the impurity atom onto the on the germanium crystal at very high speed. This is the most important point, at very high speed. Okay, in this process we bombard whom? We bombard the impurity atom onto the germanium crystal, onto the germanium crystal. Okay, due to which what is going to happen? Due to which the germanium atom will move out of the crystal, right? It will move out of the crystal and then what is going to happen? And the impurity atom will take its place. The impurity atom will take its place, will take or accommodate its place, right? Whatever you want to say. Okay, or basically it will replace the germanium atom. Okay, so this was the overall idea, and you can look over here. See, as soon as it is striking at this particular point, so it is replacing the germanium atom. Okay, why? Because the atoms which are striking on the germanium crystal, it has very high speed, right? So obviously it will create certain impact. Okay, and due to which the germanium atom will be ejected from the crystal of the germanium, and this particular atom, that is impurity atom, it will take its place. Okay, so this is the overall idea of the entire concept. Okay, so I really hope that you understood, like you not only understood the concept of extrinsic semiconductor, but you also understood what exactly a doping is and these steps or the procedure of doping, and most importantly you also understood that, like, what is the reason behind going with extrinsic semiconductor. Well, the reason is quite simple, because extrinsic semiconductor helps to increase the conductivity. Okay, helps to increase the conductivity. So by this what we can actually say is that at room temperature as well we can operate various devices, right, which we were not able to do if we are designing various devices with the help of intrinsic semiconductor, right? So this we can easily do at low temperature or even at room temperature with the help of extrinsic semiconductor, as the conductivity for extrinsic semiconductor, it is very, very high. Okay, and you also understood the two process or the two methods of doping. One is heating. Okay, so when we heat the germanium crystal, so what is going to happen? The expansion will take place of the germanium crystal, and as the expansion is taking place, so therefore the intermolecular spaces or the intermolecular distance between the atom, it will increase. And in this scenario, what is going to happen? The impurity atoms which are present in the surrounding atmosphere, it will try to accommodate itself in that particular intermolecular distance or in that particular intermolecular space, right? So this is the overall idea. And after that we saw the second process, and that was by bombarding the impurity atoms onto the germanium crystal. And you see, as it is bombarding onto the germanium crystal, so it will make sure that, you know, whatever the atoms that is present over here, okay, it will be getting it will get ejected out of that particular germanium crystal, and this particular atom, it will replace that particular germanium atom, right? This particular impurity atom, it will replace that particular germanium atom. So okay, so this was the overall idea about extrinsic semiconductor and doping. Okay, I really hope that you understood, you know, the things that you had studied till now. But still, if you have any doubt, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask me in the communication section. I will surely help you out there. Okay, so thank you for listening me patiently. I'm ending this video over here. Thank you.